Okay, in this section, multiplying rational expressions, we are going to basically look at some rational expressions and what happens, we multiply them and we have to simplify them. Before doing that, let's do some review of multiplying fractions, because rational expressions is a form of a fraction. Fractions are numbers. Rational expressions, they have variables in them. All right, so from previous grade or classes, math classes, early ones, probably grade 4, 5, 6, around there, when you multiply fractions, so example A, 1/2 times 3 over 5, if you remember, you basically multiply the numerators, you multiply the denominators, and that's where they are going to be. So if you're multiplying the numerator, 3 times 1, that goes in the numerator, and 2 times 5 goes into the denominator. It was simple as that, and you multiply, you get 3 over 10. Okay, so that was the very first thing that you remembered or you did. Now if you move into example B, now there's another level to that, so we could still do what we just did. So right across again, you multiply, right, multiply again, and now what we will do is that instead of, so we can do 7 times 3 in the denominator and 3 times 1 on top, but we can actually simplify. So the answer to this, yes, the answer to this is 3 over 21, but we need to reduce or simplify that fraction. So 3 goes into 3 once, 3 goes into 21 7 times, so the final answer will get 1 over 7. So the idea is to not do the multiplication and simplify first. So in here, I can actually simplify 3 and 3 before even multiplying. That makes it easier. And even one step before that, we can do this. So if I rewrite this again, all right, I can actually go ahead and simplify right at this part, right there, this junction where 3 is actually divided by 3, the numerator and denominator have common factors of 3, I can divide that right away. And then I will just get 1 on top, 1 on the bottom. So 1 times 1 is 1, 1 times 7 is 7. So this was a shortcut of reducing the final answer when you're multiplying fractions. We're going to use this extensively when you are dealing with multiplying rational expressions and therefore reducing them. Okay, we have 2 rational expressions. We are multiplying them. The question is basically is multiply and then simplify. Okay, that's what we're going to do. We want to multiply them and then simplify them. All right, let's go through this, and remember again, factor, factor, factor. Everything has to be written in a factor form. Let's go through and factor that. So the top, you can factor the 2. So 2 numbers you multiply, you get 10. You add, you get 7. So that's 5 and 2. Denominator, 2 numbers you multiply, you get -6. You add, you get 1. So that in this case would be minus plus 3 minus 2. And you double check again. All right. And x plus 3 up there, and x plus 5 is in a denominator for second. All right. Now, this is the part. You can actually put all of these in brackets beside each other and then divide, but right away you can do the division of the numerator and denominator as long as there are common factors involved. So here it is, x plus 5, x plus 5. Those are common, dividing. So this line is actually an invisible line. You can take out this multiplication and put them all across the line right across, and then that would be the numerator on top, the denominator on the bottom. Okay, and then the next one is that you can simplify x plus 3 and x plus 3. Anything else we can divide. I keep saying cancel. It's a common mistake. It's not canceling. Canceling means 0. So dividing. All right. So what else is left is final answer x plus 2, is on top right here, and then x minus 2 in the denominator. And that is basically it for this. The only thing now we need to talk about is that, how about, while we're at it, what is the NPV? Now, NPV, the non-permissible values, remember, you always have to look at the original. So look at the original expressions. Okay, not the simplified form, the original. Now, in order to get that, you need to actually put it in a factor form and then look at each of the denominators and then go from there. All right, I wrote down the denominators, x plus 3, x minus 2, and x plus 5. They're all here, x plus 3, x minus 2, x plus 5. Now, each of these brackets, think of them as one number, the entire thing. So x plus 3 is actually a number when you put values in there for x. That cannot be 0, because 0 times anything, 0 times x minus 2, that becomes 0. So what would be the value of x that makes that actually 0? Well, x cannot be negative 3, because if you put negative 3 in there, negative 3 plus 3, that is 0, and that cannot be. So that's your non-permissible value there. Same thing again, x cannot be minus 2 for the x, plus 2, because that's a minus. And then the last piece, which is x cannot be equal to negative 5. These are your NPVs, non-permissible values. They make each of these, when you plug them back into the original, they make each of these expressions undefined. These will make all both expressions undefined, and because of that, we call that non-permissible values. Let's look at dividing rational expressions. Review again quickly. So let's suppose we have 1/2 divided by 3/4. So if you remember, division of fractions is a multiplication of the reciprocal of the second fraction. So 1/2 we write down, we do a change the sign of the division to multiplication, and then you flip, you actually interchange the denominator and numerator. So that's called the reciprocal, and then you multiply that. So the reciprocal of 3/4 is 4/3. So basically you're doing this, you're flipping that over, and that comes down like that, if you remember that. So now you write across again, so 4 divided by 6, and then you could actually then simplify it to 2/3. Okay, example for division of rational expressions. This is the question, copy it down, and then there's a division there, and then remember, factor, factor, factor. So we got to put everything into factor form. So factor, and then we go ahead and then do the simplification. Change the division into multiplication, and then you flip the denominator, goes up, the top comes down, and put them all in a factor form. All right. Okay, so I put everything in a factor form, and check, make sure you're right. I change the division into the multiplication, and then I use the reciprocal. I flip that. So the denominator 3mn squared n minus 3mn squared was up here, right here, and then I factored the GCF 3mn out, and then I did the same thing with top. The top 9m squared minus 4n squared is actually difference of the squares. So now you go ahead and then you simplify. Okay, divide common factors. Okay, so let's start doing that. 3m minus 2n, 3m minus 2n, so they can divide. We have m minus n on top, and one of these guys, let's choose that one. That would be dividing, and that's it. That's all we got, nothing else. So now that we have that, you write the final answer. The top 3mn, that's the numerator. The denominator is m minus n, and then 3m plus 2n in a product form, because we have this and that, we have to multiply them. And that is it.